This is a video on section 2.7, part 1, and we're going to talk more about derivatives today. So in a previous class, we talked about the general power rule, which when you use the power rule for the outer function and then you multiply it by the derivative of the inside. So for example 1, let's recap this. So 1a is saying find the derivative of s. So s is, instead of using y and x, we're using s and t, which you're going to see in 2.8 why that's going to be a common variable, two variables that we'll use. So find the derivative of s with respect to t. So doing this general power rule, I notice I have this big piece raised to a power of 10. So I'm going to bring the 10 down in front. So ds dt equals, multiply that 10 by 3, those 30 times this whole inner function to the 9th power, because subtracting 1, but then we have to multiply by the derivative of the inside, so 2t plus 5. So that would be your derivative with respect to t. Okay. Same is true for b, and notice that we're doing the derivative with respect to t. So t is your variable here. Anything else, like you notice there's other variables in here, a and s, those are standing for constants. So again, just think of t as what's your variable here. So when I do the derivative here, there's no outer function, so it's just with each term taking the derivative with respect to t. Remember, a and s are constants here, so it'd be 2a t to the first minus st to the negative 2, and the derivative of s squared is just 0, since s here is a constant. So that would be your derivative for part b. So now we're going to talk about higher order derivatives. And again, in 2.8, we're going to see what this actually means. We know the first derivative stands for the slope of a curve at a particular point. And when we find it in general, it can be used for a particular point when you plug in x. But then taking the derivative of that derivative, well, that's called the second derivative. So when you take the derivative, first derivative is when you take it initially with the function. And the second derivative is when you take it again, so taking the derivative of the derivative. And you can see it's denoted, instead of f prime of x, it's f double prime, so those two little quotations there. All right, so let's find the second derivatives of these functions. And in order to do that, you first have to find the first derivative, which makes sense. So let's do that. So the first derivative for this first one, using the power rule, for each term, 2x minus 3. So then when I do the second derivative, which means taking the derivative of what I just found, that's just going to be 2, because the derivative of minus 3 is just 0. All right, for the b, again, the power rule. Actually, before we do that, let's just rewrite y as 3x cubed minus x to the negative 1. Bring that x up. Now I can do the first derivative using the power rule. So 3 times 3 is 9, 9x squared plus x to the negative 2. And now the second derivative will be the derivative of that, so 18x minus 2x to the negative 3. All right, now this final one is the derivative, where f is in terms of t, same idea as it is in terms of x. Go through the same process. So f prime of t is going to be 1/2 t to the negative 1/2 minus 1/2 t to the negative, if I subtract 1, I get negative 3/2. And then let's do the derivative again. So the second derivative is the derivative of the derivative. So negative 1/4 t to the negative 3/2 plus 3/4 t to the negative 5/2. So as you can see, the process is the same. You're just taking the derivative of the derivative. So a little bit on notation here. So let's just look below. So the first derivative, and it all depends, of course, how you define the function and what variables we're talking about, but say it's x and y. First derivative, we've seen f prime of x. Sometimes we have y prime. Sometimes we have dy dx. Sometimes we have d dx of y, and so on. Whereas the second derivative, if I take all of these, you've just got the double prime or y double prime, or instead of dy dx, we often say d2y dx squared, or dy dx of dy dx. So it's taking the derivative of y in terms of x. So those are just some notations that you might see. Now let's look at notation at a specific value. So say I wanted to find at a specific point A, it would be f prime of A, or sometimes say I wanted to find the derivative of y with respect to x, say at x equals 1. We might use that notation there, or f prime of 1. So different ways of just getting used to the different ways of notation of how to find the derivative in general, and also how to find it at a specific x value. So let's do this third example here. So it's giving you what y is in terms of x, and it says find d2y dx squared x equals 3. That means find the second derivative of y with respect to x, and then plug in when x is 3 to find what that second derivative is at x equals 3. Okay, so first let's do y prime, or the first derivative. And the first derivative will be 4x cubed minus 15x squared. Then the second derivative will be 12x squared minus 30x. And now the notation said find the second derivative when x is 3. So we're going to do the second derivative, or y double prime of 3, is going to be 12 times 3 squared minus 30 times 3. 12 times 9 is 108 minus 90, so that's going to be 18. Okay, so then what the homework or the practice problems are getting used to finding, practice doing the first derivatives. That will be the first group of problems. Then finding the first and second derivatives. And then a little bit more applications, finding first and second derivatives at specific x values. And then the hardest will be the last group of problems, which is finding, you'll have a function in terms of 3 different variables, and really finding the first and second derivatives in terms of specific, which means that, well, let me go to it to show you. So let's see. Okay, so this is 15. So you want to pay attention here on what you're finding the derivative with respect to. For example, in A, it's saying find the derivative of this function with respect to x. So x is your variable in this case, and everything else is going to be thought of as a constant. So if I were doing, so try that first and then pause this, and then I'll walk through these problems. So try it first. Again, for each of these, the denominator part is saying what is your variable, and the other pieces are going to be thought of as constants when you take the derivative. Okay, so you can unpause if you want to see how this is done. So first, in order to find the second derivative, I've got to find the first derivative with respect to x, meaning x is my independent variable here. So y and z are going to be constants. So if I take the derivative with respect to x, I've got x squared, so that 2 comes in front. So it's going to be 14xy square root of z. Y and square root of z are not changing because those are thought of as constants in this case. So now if I do the second derivative, so the derivative of this, the coefficient of x, or the constant, so it's x to the 1, so the 1 just comes down, so it's just 14y root z, and then it will be x to the 0, or 1. So it's just these coefficients, 14y root z, because it's x to the first power. All right, different in B, because the variable we're talking about here is y. So if I do, and everything else is going to be thought of as a constant. So if I do the first derivative, it's y to the first, so I'm just taking everything else, 7x squared root z. And again, the x and the z in this case are not variables. They're thought of as constants. So when I do the second derivative, If 7x squared and root z are all constants, the derivative of a constant we know is just 0. So that's kind of weird in that case. All right, so the last one we're talking about z being our variable. So let's rewrite what s is first, because I don't want that root. So if we think of s as 7x squared y z to the 1/2, again, z is my variable here. Everything else we're going to think of as a constant. So ds dz, bring the 1/2 in front. So it's 1/2 times 7x squared y z to the negative 1/2. Or in other words, if we clean it up a little bit, it's zx squared y over 2 root z. So that's just getting used to, even though there are 3 variables, depending on what you're finding the derivative with respect to, the others are thought of as constants. So again, that's a little bit weird.